Hey folks, thanks for joining our talk today. We're going to give you a little bit of a background on Shipa and our cloud native application management framework. And before we talk about Shipa, the reality is that a lot of the platform engineering teams today, they're spending between 1 and 2 years to try and build a platform for their developers where applications can be deployed. They spend that time basically gluing up a lot of components together, YAML files, custom scripts, and so on and so forth. And great, now that the platform is built, we give Kubernetes as the interface to our developers. But what's actually happening is, as soon as developers they start deploying the applications, they see that this is actually dragging them down to the infrastructure layer level, where they have to learn, manage, and create things such as deployment sets, ingress rules, custom scripts for development. Many of them, they have to learn Terraform, so on and so forth. And what they're reporting back is that application deployment now and updates, now they have become more complex than before, because now they have to learn a bunch of infrastructure components rather than just the application itself. The developers, they complain that they're spending a lot of time on tasks that are infrastructure related instead of application purely, and that's fair. The value they deliver is the application and its updates. And because developers, they are being dragged down, the possibility of pushing misconfigured files all the way from your CI pipeline down to your Kubernetes cluster is real, and that can change the state of your cluster and the state of your applications. But that's not only it. From a platform team perspective, what's happening is we spend that 1 to 2 years gluing everything together, bringing together those scripts and those Terraforms and YAML files and so on. But as soon as applications starts to be deployed and we start to get some scalability, now what happens is Kubernetes is very object-centric rather than application-centric. And what I mean by that is it becomes really hard at scale for us to implement security, controls, and policies at an object level rather than application. So in order to try and mitigate that, what we see a lot of folks doing out there is they try to create more YAMLs, more script, more Terraform to try and fix that, and at the end of the day, we just create more complexity. And when supporting application is up to the task, it becomes really hard because we've seen many people saying what is actually an application of Kubernetes. We're no longer looking at an application level, but now at an object level. So we need to see what are all the objects that are related to my app, what's the health status of each of them, so it becomes really complex. And now we're getting a lot of pressure from our developers, actually, because they don't like that interface. They don't like being dragged down into the infrastructure. And at the end of the day, what we're actually being tasked with is, can you deploy yet another platform? So that's the question that we're faced today. So in order to try and help with that, we started thinking about it a bit differently, in a way that, why don't we think about an application framework rather than individual solutions or cluster-focused solutions? So we started thinking about that. And when you think about an application framework, what would that look like? If we think from the lenses or from the perspective of the platform engineering team, we would have to look at some of the functionalities that some of the platforms out there, such as Heroku and OpenShift and others, they give us, such as RBAC, connection to third-party apps, some automated routing and monitoring. And even though this is great, and I think this points us in the right direction, the way we see that at Shipa, these are table stakes, and that cannot really get you farther in the world. So in order for that to be effective, you have to come up with more components, or that application framework has to offer you more components, such as integrated security, multi-cluster support. I'm pretty sure many of the organizations out there, you are implementing multiple clusters, either on premises, managed cloud providers, and managed Kubernetes versions, and so on. We don't like ripping and replacing everything. So that for that application framework to be really effective for us, it needs to fit right into our current stack. So it needs to fit into our CI pipeline, and it needs to fit into our monitoring tools, our incident management, and so on and so forth. And it needs now to fix the last mile deployment. A lot of us are spending a lot of time today trying to actually piece together our CD tools that are out there and our Kubernetes clusters. And a lot of them forces you to actually have to build custom scripts, Terraform scripts, and so on, and they are not really doing it well. So we need something, we need that application framework to actually automate that and make that completely seamless. So the application can flow from my Git repo all the way to my Kubernetes clusters without me having to intervene and maintain a bunch of custom scripts. And last but not least, a lot of folks, they don't like hearing that, but the reality is, if you are implementing Kubernetes today, it's because you changed what you were implementing, what you implemented actually yesterday. So the reality is, you are probably going to be looking at changing Kubernetes in the future, or changing cluster versions, or maybe changing cloud providers. So that application framework, it needs to be extensible, so we can swap components underneath it, and the developers and the applications, they will not be impacted. From a development perspective, same way. We can look at table stakes type of functionality, where they have some automated logging, monitoring, some support to canary and A/B releases. But for that to be effective and lasting in our organization, we need to allow our developers to stop thinking now about object on Kubernetes and really focus on the application. It needs to fit their workflow, so it needs to fit the CI, and it needs to fit what they're doing from a Git repository perspective, either GitLab, Bitbucket, and so on and so forth. It needs to decouple the APIs and give them self-service APIs, as mentioned. If we want to change Kubernetes versions or cloud providers version underneath, that cannot affect our developers. So they need to be working at a level up and a decoupled self-service API. Although there needs to be security, we need to actually detach our developers from that in a way that it is embedded in the process, but they don't have to learn and know how to create that. And we need to give them more observability. Again, we've seen a lot of developers and even platform engineering teams saying that they need better observability. But what we understood from that is that they wanted to see how their applications are actually behaving and the components related to it. So we need to give them that. And it also needs to be extensible. So how do we implement that framework? Let's say we as a platform engineering team, we create a framework spec, and that framework spec is completely abstracted from Kubernetes. There's nothing related to GKE, on-premise Kubernetes, K3s, and so on, but it's related to your application. And here you're gonna define things such as the amount of memory and CPU and swap your applications that are deployed using that framework can consume, the level of security scans, and any vulnerability exceptions you want to open, if any, what teams can have access to, services that you want to attach to this pool and to that framework and make it accessible to applications, all the way down to network policies. So every application deployed using that framework can automatically consume that type of network policy. Once attached, what you can do is, once defined, you can attach actually that framework to a cluster. Reality is, one single framework cannot address all the requirements from all the apps we have. So we can define multiple frameworks, and these frameworks, they can have different configurations, security, teams, network policies, and so on. And you can now attach these frameworks to different clusters you have. And by attaching them, these frameworks are automatically gonna start giving you all the functionality, or giving your application the functionalities we discussed before. And the great thing about it as well is it starts attaching into your existing infrastructure, so all the applications that are deployed using them can automatically consume them. And on the developer side, what we do is we allow the developer to keep using the same Git repo, the same CI tool, but now instead of us building a bunch of CD scripts and Terraforms and Helm charts to make our CD tool or even our CI pipeline deploy to Kubernetes, we attach this CI pipeline to your frameworks. So you don't need to build anything. Forget Helm, forget Terraform, forget scripts. They now connect directly to these frameworks. And a few other things happen here actually. Your developers, they don't need to build a single Kubernetes object. They actually could care less if it's running Kubernetes. They don't know if it's GKE, AKS, 115, 114, 117. They are solely focused on deploying their code. And as soon as the CI deploys the application code, just the application code, no objects, to that framework is then now responsible for creating all the apps automatically. So now we have a very structured, automated CD component that is going to get our applications not only from the Git repo all the way to deployment without being worried about infrastructure, but also post-deployment, where we have monitoring hooked up, we have security, we have network policies, audit, and others. At the end of the day, using the application management framework as part of your CD process and post-deployment as well, it accelerates the Kubernetes adoption. It removes completely the need to create YAML and object files. No more scripts and Helm charts and Terraforms for your applications to be deployed. And you allow your developers to be focused on the application, so they're finally happy with the platform engineering team. And we as a platform engineering team, now we're focused on controls, extensibility, performance. So we become now a key piece in our team and in our organization, instead of just being a bunch of YAML engineers, right? So the goal is developer experience and speed, extensible application framework that allows us, the platform engineering teams, to be the hero in our organization. Thank you.